Okay, this will take you through this question by hand and also using your graphics calculator. First, let's have a look at the equation. Just by looking at it, we can see that it is definitely going to be a growth function. Right, why is that? Because time has to be positive, but also this part here, the base, that is greater than 1. And what that is actually doing, it's increasing by 7%. All right, so 7% as decimal is 0.07. If you add on that 1, that's increasing every time by 7%. Anyway, how would we do this question? Find the initial weight. So what I would expect you to write down, we know that this is wanting when t is 0. Let's use our beautiful notation that we have learned before. So I would expect you to say w of 0 and actually write down what you're going to substitute in, just so you know I can give you a mark for that anyway. And now we don't even have to go to our calculator because we know anything, right? Anything here to the power of 0 will be 1. And so 1 times 100 is just 100. And don't forget, let's put your units there. What are we doing? That's grams. And then we think, oh yeah, of course, because this is actually our initial base weight. That will be the situation for all of these types of questions. All right, and then for B, we're going to do the same thing. All right, for when t is 4 hours. Once again, I want you to use your notation, so W of 4. Okay, and wherever t is, you're just going to replace it with 4. Probably didn't need me to do any of this. Use your calculator. Okay, we're just in our normal mode now. We will look at the graphics calculator in a momentito. Okay, 131.1. Let's go 1 decimal place. Okay, let's go to 131.08. And then similarly, we will do the rest for 10 hours and 24 hours. You don't need to see me do that. So hopefully you got the same answers that I did. And again, can't stress enough, can you please make sure that you show the correct notation? Okay, show that line of substitution. I can't stress how important that is. All right, now for part C, sketch the graph of the bacteria. So keyword here is sketch. It's not draw to scale or anything, but you'll still need to use a calculator and be reasonable. So I'll just set up my axes. Get your axes drawn like so. First thing we do is label them. So this will be the time, and then we've got our weight. And if you really want to be impressive, you'll put the units that we're measuring there. Okay, and time is in hours. So remember we said this is a sketch. Our minimum is 100, and then our maximum is 507. So we'll just sort of go up 100, 200, 300, 400, 500. I'm probably regretting not sticking to my little dashes there. And we want to go all the way up to 24. So again, you know, we could go 0, we've got 10, 20, 30, and so on. Okay, so initially we've got here, and make sure that we actually pop that there as 100. Okay, after 10, so we've got 100, 200. I did say it doesn't have to be to scale, but it sort of sometimes helps you plot these things. Anyway, so that's about 196. We've got 24 is about 500. 2, 3, 4, 500. It's not going to be the best. Draw that in. Nice smooth curve. Okay, and I guess you could even pop in that the 4 was 131. Okay, when the question has said to pop them in, I guess you might want to actually draw in some of these figures that you got. Oops, that was not a very good one, is it? Anyway, so there we go. Use technology to graph. All right, let's do that really quickly. So go to number 5. We type in our function. It was 100 times 1.07. Now to the, you don't want to say to the 4, to the 10, to the 24, because we say to the x. That's the thing that's varying. All right, we go to our view window, it's at standard, so we're going to change that. We're going to go to 0. Looking at the question, it said maximum of 24 hours, so I'm going to have a bit of a buffer, and I'm going to go up to 30. We draw. I don't expect to see anything. Right, from the information we had, we could have actually set our Y values, but I'm going to use our bestie, Shift Zoom, Auto. Okay, be careful, because do not draw this to make it look like it's coming up from the origin, like here. Right, that would be wrong. Wrong, 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 wrong. So what I always like to do is I like to go back over to my view window, and I like to go back and see my axes, my x-axis. So I put 0 there. Sometimes I even put a negative. All right, and there I can see my x-axis is at the bottom. Okay, so show you what I mean. If I put sort of a minus 50 there, you actually see the axis itself. Right, so how could we have got all of those values before? Well, gsolve, we could have gone our y-intercept for the original when time is 0. Okay, gsolve ycalc when x is 4. So we always double check, all right, just in case we've made an error. So even if it didn't ask you to do it by calculator, bang, do it really quickly. And of course, you know, if it was an xcalc, how long would it take for the bacteria to reach 400 grams, which they didn't ask us. They could have to read off your graph. There we go. That's it in a nutshell.